them, brings them up through training, mentors them, and then pretty soon they're the next layer up, and then the next person helps them, and like they just kind of work their way, almost like, hey, I worked for a utility for 40 years, kind of thing.
Right.
Started as a
Right.
lineman, right? Um, and then there are other people that just sort of like just pop into existence. I was a writer with Consumer Reports for 30 years, and suddenly I'm a researcher for renewables or something.
Right.
So anyway,
Yeah.
that's to set the expectation that this is part of. I see this as a valuable brick in a whole wall of resources that can point people to this is what the future could hold for you, and this is so keep the faith and don't get discouraged when it's finals, kind of thing.
Yeah.
Yeah.
Yeah. Anyways, Remy, I'm sorry to interrupt because I know you have a whole shtick that you need to make
No,
through.
you're fine. And I just want to, we started the recording. So, first of all, thank you and welcome to our College Student Network call for February 2026. Um, we are just going to start out with some opportunities coming up from Repowering Schools, and then we're going to turn it over to our speaker for today. Just a reminder about all of our industry events that we engage students in as we move forward in the year. Most of these events are in the fall, so just put them on your calendar now, and applications to participate in our different career experiences will be, sorry, conference experiences will be opening up later in the year. We are bringing 11 students to the Distributed Wind Conference in Arlington next week. It is also one of our student symposiums, so students have the opportunity to give an oral presentation. There is a poster reception. We have an industry panel. And we will be taking a visit to the AES headquarters and hopefully getting a visit from some folks from Google to learn more about how they work together. So it's going to be a fun couple of days. And then the very last thing we get to do this year is we get to lobby with the DWF folks up on Capitol Hill. And meet with our legislators. So it's going to be a really cool week. And next month, we'll give you a quick recap from that event so you can hear how it went. I also want to remind folks that this Google Solar Scholars program, one of our new programs under the Energy Academy, is now open for applications. This is a 5-week intensive course for college students. There is a virtual learning component, but then there is also a hands-on field experience component. So we are asking that students that apply are residing in Virginia for the summer to be able to take advantage of those in-person field experiences. And those applications are due by March 15th. So we have about another month before those are due. The other thing that we want to let you know about is our newest seed funding opportunity. We are working with AES. They have $20,000 in seed funding for up to 4 student teams to develop and implement some community-focused educational programming for their campuses around civic engagement, stakeholder and community engagement, in order to prepare folks to apply for that funding opportunity, knowing that maybe a lot of folks don't really know what stakeholder and community engagement looks like. We have a virtual learning series. It's 2 webinars that you can attend. Then you'll get to learn a little bit more about stakeholder engagement and some of the more common practices so that you're well versed in order to propose a project for the seed funding. The links are in here. I will also email this out to the network, the direct links to join the virtual learning series. So you have to RSVP and register on Zoom, and then the seed funding opportunities. You can read more about that. Also, remember that we have our Repowering Careers program that is under development and will be coming in the fall of 2026. We hope we'll have applications or at least more information available by April for that program. And we are currently working on our alumni and ambassador program. So if you're super excited to participate in Repowering Schools' programs and get super excited to help us do more, stay tuned for more about that program going forward. And then last but not least, our Renewable Energy Education Awards program is now accepting applications. So please think about nominating someone today. We have categories in outstanding educator, student excellence, industry champion, special recognition, and then repowered schools. Those are schools with renewable energy technology installed that are also doing cool things in the classroom with that. So you got to walk the walk and talk the talk. And we look forward to seeing your nominations. It's a pretty light lift nomination, and those nominations will be open through April, I think. So you have a lot of time, but we look forward to your nominations. Just a quick reminder before I pass it over to Charles to introduce our speaker that all of our webinars are recorded and available on our YouTube channel. Lots of other resources there as well. So I highly recommend you follow us on and subscribe to our channel on YouTube. Okay, and with that, I'm going to turn it over to Charles to introduce our speaker for today. And I'm going to go ahead. Did you have slides, Bree, that you wanted to share?
Sorry, I don't have slides. We're
Okay,
gonna,
that's completely fine.
all right.
No slides is just fine to me too, because it's a conversation as much as anything. So,
Mhm.
Bree, thank you so much for joining us today. And let me see if I can get out of the shared slides so that I can see. Or do we need to see that anymore? Maybe we can just stop sharing.
There
Okay,
you
cool.
go.
Perfect.
Great.
Amazing. Then now I can see Bree. Thank you. Because I'm calling in on a phone and it's one of those things I haven't figured out how to do everything. At any rate, okay. So Bree, thanks for joining us. As we were saying before the call officially started, that the value and the role of these kinds of sessions is to give people a window into what a career might look like, or
Yeah.
a career path might look like, or you're at a specific point and you can describe what you do now, but you can also describe some of the things you've done in the past that got you where you are. Um,
Sure.
we would love to hear a handful of things. So number one is sort of like, all right, you're an engineer. What made you want to be an engineer? Would you come out of the womb knowing you're going to be an engineer, or did you like have an influential person when you're in ninth grade who, right, that kind of thing? Like, how did you decide to be an engineer? Where'd you go to school? What was it like? And then what was your first job like and how awful was it?
Yeah.
Right, right. And then how did you parlay whatever experiences you got to end up to where you are, which in my opinion is an extremely cool place. And just without going through your bio, I'll share what I know about you and what I've seen. And what I've seen is that I was introduced to you last summer or so, through Ingenuity, and that I didn't know who Ingenuity was. Somebody said, "Hey, you should meet with these guys because they're
Yeah.
doing cool stuff." And I sat down with you and Jeff, and I'll be darned, you guys are doing really cool stuff, and the kind of products that you develop and just the out of the box thinking that you do, and then the desire for Ingenuity to move into the green space a little bit, be figure out how to do that because you're involved in mining, which is it's not coal necessarily, it can be hard rock mining. And like your sensor that goes on that bearing is just amazingly cool in terms of the payback or the risk reduction of that and the value of that. So something along those lines is really a neat thing what Ingenuity is doing. And then I saw you and I'm like, well, wait a minute. Bree does cool power conversion stuff. Bree has this whole
Mhm.
background. And then you and I had been at the Colorado Startup Week together and shared our stories. And so I thought, okay, you're a perfect person to just share in this environment so we can kind of get a
Yeah.
sense of, okay, this is what the world can look like when you graduate and you can be off leash and go and play. So with that as
Yeah.
the intro, we'll get you started and then I'll take notes and then I'll ask you questions as we go to follow up. And if other folks want to join into the party and ask questions, we'll invite them to do that.
Yeah, I'll start with where I'm at right now because yeah, I do think it's a pretty exciting. So I'm working at Ingenuity Design Group. It's a small consultant company. We do product design. Um, and we've got about 12 people here at our office in Golden. And then we actually have an office, three offices actually in Sydney and one in the Philippines. So we're an international company. And my boss started it in Golden about 6 years ago now, in 2020. And So what we do is we design products for people who want a new product to be made. So that can be big companies that want to do something, and it could be a startup company. So right now, like some interesting projects that we've got going on are a swappable battery pack for ground support equipment, electrified ground support equipment vehicles at airports. And that's a really technically challenging project. And then another example is a computer all-in-one like Windows tablet that is basically an oscilloscope, all, for measuring signals on a vehicle. So that's used by the California Bureau of Automotive Regulation for testing vehicles and making sure people aren't cheating their way through emissions testing and whatnot. Um, and so we take on all kinds of projects, and they're very technically challenging. They're very diverse, which I think is probably the thing I like most about it. Which I think will be kind of relevant in how I got here because I've been at this company now for about 4 years. And throughout my career, I've kind of spent like 3 to 5 years at companies, and then I've kind of gotten bored and moved on. And I don't see myself getting bored at this company because we got so many new projects all the time. Um, but I started I decided that I wanted to be an engineer in high school. And I guess wanted to be an engineer is maybe a strong word. I never was the type of person that knew that I wanted to be an engineer. I know a lot of engineers that are like, yeah, at the age of like 5, they just knew they wanted to be an engineer. My boss is actually like that. Um, and I know a lot of other engineers they've got that mindset for building things. They love building things. And I think for me, I'm a little bit different, I think, in that way. I think I enjoy working on a team. I enjoy working with people. And so there was aspects of engineering that I heard about that sounded fun. Specifically just people who are working on teams building stuff. And so that sounded really cool. I also kind of knew I would not fit super well in like other fields, like uh, anything having to do with like memorization was not my forte. So with engineering, you can kind of derive the whole way, from a few ground principles, and that seemed to jive with my brain. Uh, and I did pretty well in college when I got into engineering. I focused on electrical engineering. My dad was an electrical engineer. He was actually the manager of utility and had that very linear growth through his career, like you were kind of talking about. He basically started as an engineer and then eventually was promoted and made his way up to general manager. And I kind of knew I didn't want to be on that side. I don't know why. I just think I wanted to pave my own kind of path through engineering. And I think electronics in particular, just like circuit boards were kind of fascinating to me. They seemed mysterious, like an un kind of a territory that felt like uh unique that I kind of wanted to get into. And so um yeah, I did my bachelor's degree at North Dakota State University in Fargo, North Dakota, which is where I'm from. And then when I was a sophomore or junior, I can't remember, but there was a local company. They're called John Deere. There was a branch of John Deere, and they did a lot of the electronics for John Deere equipment. And they had a posting for an internship, so I applied. I got it, got the position, and then the next 2 years I spent there working as an intern underneath on a team of people that were building up traction inverters for hybrid electric construction equipment. So uh, that was kind of they call it a series hybrid where a diesel engine is powering a generator, and that generator then goes through an inverter, which then is powering a motor. if that makes sense. So, that was, that was back in 20, I got into that. So I graduated in 2000, December 2009. So that would have been about 2008 that I got into that. So electric vehicles were still sort of new. Like Tesla was still kind of a startup company that people didn't really believe in. Even the people I was working with, I remember, didn't really believe Tesla was ever going to make it. And we kind of were working on these electric vehicles, but batteries hadn't really come along to the point where they were at right now. So it was kind of a new territory. I think John Deere was the first one to release a hybrid electric construction front end loader, which our inverter was what went into that. Um, so I learned a lot about, you know, ground up design of traction inverters, and I learned a lot about motors and generators and all the different types of electric motors. And by the time I graduated, I kind of saw where the world was heading in terms of, electronics and power in this way, like, you know, and also I believed in it from a standpoint of just like, where we needed to head in the world. It seemed like, uh, we needed to consume less energy and become more efficient and use more sustainable energy sources. And I kind of had an aha moment, I guess, where I realized, like, again, batteries weren't where they were at right now and they're at now. And so remember thinking to myself, well, no matter what the next generation of energy sources are, they're going to need power electronics in the middle, right? So this conversion of energy is going to happen. So I figured I'll be okay no matter where the world goes, as long as I, pick my career as this like intermediary in between the source of power and the use of power. And so when I graduated, I actually was offered both a software position and a hardware position at John Deere. And my my boss at the time, he encouraged me to do hardware because hardware, in his words, is at the middle of everything. You're kind of telling the software engineers what to do. You're working with mechanical engineers to make sure you've got all the mechanical interfaces lined up, and then you're working with the manufacturing team as well. So there's just the hardware is kind of at the center of everything, and so it's a very dynamic job. It's a very exciting job. He convinced me of that, and so I decided, I'd focus on hardware, and I have never looked back, I guess, since, or if I have looked back, it was too much work to switch at the time, so I've just stuck with it. Um, but yeah, I worked at John Deere after I graduated. I stayed there for 4.5 years. And then we finished up a couple of those major projects that we were working on. There was kind of a lull of like where I was going to go on next. I was getting kind of bored. There's a lot of paperwork at the end of a project, um, which I don't want to belittle. It's very important that you do that, but it can be very boring. And at that, I was, in my mid 20s and I wanted to do something new, but I wanted to kind of build on my foundation that I built in this type of technology. And so I actually went to Germany and did my master's degree in Germany, focusing on power electronics, electric drives, this kind of broad field of um, power engineering. And so um, that I think was one of the better decisions in my career, partially just because it kind of gave me a break from, being in the vicious cycle of capitalism, and it can get very daunting, I think. And I was able to kind of take a break, get out of like practical engineering, get into more theoretical. Like German master's degrees are very, very theoretical. Their laboratories are, I found, a little bit less involved, or at least, coming out of industry, it was far less involved than what had been experiencing. But the theoretical knowledge that I had to have in order to get through those classes was pretty intense. And so it really, you know, I coming out of bachelor's, had a pretty decent foundation. John Deere gave me very good practical experience in electronics and power electronics in particular. And then getting a master's degree in Germany really solidified the theory for me. Um, so then, long story short, came back from Germany after about 2.5 years of studying over there. I worked for a few different companies over the course of like 6 years. I'll kind of skip through those. Still focusing on electronics, still focusing on traction inverters in particular. And I think after about 6 years, I knew there's a much more broad field of power electronics and energy conversion and products, and like traction inverters for electric vehicles is fun. But I wanted to get into something new. Um, and I wanted to get out of stuff that was like 300, kilowatts, like dealing with kilowatts of power. That process is very slow. When you're working with high voltage, you're working with high power. You got to make sure you don't blow stuff up. Inevitably, you do blow stuff up. Then you got to tear it all apart. It's just like everything has moved so slow. And so I felt like 10 kilowatts was kind of going to be a little bit more my field, a little bit more dynamic. And that's what brought me to Ingenuity. They were doing some interesting power electronics at the time. Specifically, they were working on that swappable battery system, and so I came on, and we've just been taking on more and more interesting projects ever since. We're constantly working on new projects. I think our next project might be a electronic discharge machine where we're building a power supply where we're controlling an arc. Um, and so I think that's kind of what I think is cool about the type of work I do, where I kind of describe it in layman's terms as we're shepherding electrons, um, and trying to do that in a very controlled way where we're not going to lose electrons. And that's, trying to raise the efficiency. My whole life is just trying to save more electrons.
Electrons have rights too, right?
Yeah, yeah,
I love that. Um, that was very nice. I hadn't actually ever gotten that nice arc from you before. Really interesting. You mentioned a few times traction inverters.
yeah.
And the first question is, when you were talking about this sort of serial diesel
Hmm.
inverter motor, it sounds a lot like a electric diesel locomotive. Is it
Yeah,
exactly
yeah.
the same thing as an
That's
electric
exactly
diesel?
the same thing.
Diesel
Yeah,
electric. Okay.
yeah, yeah. So.
And then is that so that you can manage torque more accurately, so you can deliver the right torque without slipping? Is it, it's just very precise torque control? Is that why you do it?
Yeah, yeah. I mean, you can the reason that we did it was you can spin the generator at or you can spin the engine at its most efficient operating point, right? And so you're always operating the engine at that most efficient speed. And so uh, yeah, and then you're able to convert that to electricity and then use electricity to spin a motor, and then you've got more precise control of the torque. And so in a construction environment where you're literally like slamming into you know, I don't know, some dirt, I guess, to pick it up. And you can actually do that without having to without tearing up the wheels. So you don't spin the wheels. You can control that much more precisely. So now you're getting less wear and tear on your wheels. You're getting your engines operating more efficiently, and we ended
And
up
the-
seeing like a 40% efficiency improvement on those vehicles.
Interesting. Yeah, and the coefficient of static friction is so much higher than kinetic, so
Yeah.
you get more push also. Um,
Right.
no batteries. So that's interesting. So you say it's all about the RPM, and it's kind of like, I mean, I grew up on a farm, right? And we had set our PTO speed at 1200, which was,
Mhm.
1800 or whatever on the engine. But it didn't mean that like the governor could be backed off quite a bit.
Yeah.
And so it's not delivering a lot of fuel to get your 1800 RPM. But as soon as the load comes in, now you're doing dynamic fuel on the
Yeah.
diesel side, and that is matching, but you're just operating at an optimal fuel efficiency part of
Yeah.
its curve. Got it. That's interesting. That's fascinating.
Yeah. Yeah.
Um, how is a traction inverter different from a regular, solar inverter or something like that?
I mean, basically just you're spinning a motor. And so yeah, rather than going from, solar power to the grid, or solar power to a battery or whatever, but let's say you're going to the grid, you would still, you're converting from DC to AC. It's just in a traction inverter, it's three-phase AC, and you're doing that at in order to spin a motor. So your type of control might be a little bit different. You'll use like a field-oriented control to control the rotor speed, um, as opposed to the grid, where you're, measuring the grid frequency, grid voltage, and trying to match that and push current into the grid. So a little bit different, but
Really, really interesting. I mean, so Vestas, Vestas is a big wind company, and they had something called the OptiSlip, which was in late 1996, 1997. And the Vestas V47 was originally a 600 kilowatt generator.
hmm,
It was a pitch regulated induction machine, meaning it ran at 1800 RPM,
mhm,
native or 1200, one of those, and then but the OptiSlip allowed it to vary a little bit, and so you could push it plus or minus more than the normal slip of an induction motor, like 5%, 3%, to like 20%. So then
yeah,
it acted more like a variable speed. It was kind of
yeah,
a cool thing. So it's interesting that you're kind of going back to those days, which I think was really fun. Okay, next.
yeah,
Sorry about that. Next question is, when I think about batteries, and best systems today are not using. I mean, some people, if you're using a 200 megawatt, um, uh, if you've got a 200 megawatt battery comprised of little five or 2 megawatt cubes, right? In that case, you may have a 2 megawatt inverter because
mhm,
you're going to have a bunch of them. You're going to have 50 of them or 100 of them or whatever it is. But if you're
right,
doing something smaller, if you want high reliability, like 5 nines for a data center, then you're probably going to be driven to a smaller, like a 50 kilowatt inverter, and you're going to do, whatever, 40 of them.
right,
you know, so why would you not, when you're doing a 300 kilowatt system, why wouldn't you do a bunch of inverters that are coming off of that? Just to take advantage. Maybe it's just an economy of scale thing, but I just see people using little solar inverters because they're so cheap now. That topology is
yeah,
really inexpensive.
yeah. I mean, in a vehicle, I think the reason is just because you don't want to have to like synchronize a bunch of different outputs basically. Like you won't have to, if you're driving, like let's say you're driving four different inverters with the same DSP, then you need that many more PWM outputs. Or if they're driven by different, processors, you'll have to synchronize the processor somehow
All the
to their
PLLs, yeah,
whole. Yeah. So I think in a vehicle, it's just a little bit easier to for
just do
controlling
one.
that motor to just use one. And so you end up going towards um,
Interesting.
power electronics basically for doing
Just to
that.
simplify it. Huh.
Yeah.
So I don't want to interrupt this awesome
Yeah.
technical discussion, but
Yeah,
the
we'll step
discussion
back.
that you guys are having has sparked something in me that has nothing to do with
Oh, cool.
technicality. But
Yeah,
Bree, your expertise in power electronics, I think could be amazing for these collegiate wind competition students. I don't know
yeah.
how familiar you are with the collegiate wind competition. But these are college students who have to build a turbine, right? And they have to compete in all of these different, I call it like the Olympics of, of performance control. Like they have to pick
Yeah.
their blades, they've got to brake, they've got to, Anyway, power electronics is always the kicker. Like I see these kids at the competition, they come, usually their blades are fine, things like, but they spend hours at night trying to figure out their power electronics. Anyway, long story short,
Yeah.
are you familiar that the collegiate wind competition regional competition is happening at CU Boulder this
No.
year? And
First week of May.
it would be amazing to sign you up to come to one of our industry days, so that you
Yeah.
could meet with some of these students. I think that would be a great opportunity to engage you.
Yeah, that sounds great. Yeah, send me the details. I'd love to get involved. It sounds like a good opportunity. Yeah, I think if I'll just say this to the collegiate competitors that are dealing with power electronics and struggling, that's not that rare.
And
I'm
there and
struggling
there
as we speak with some power electronics. Like these electrons just won't behave, That's
And
tough.
I will say I'm not an engineer, and Charles is super, super savvy in this
Yeah.
space, but I walk through the bullpen of the collegiate competition, and there's just like wires everywhere and like
Yeah.
oscilloscopes everywhere. And I'm just like, good thing you know what you're doing. Like I can maybe talk about, project development, but this is not my
Yeah.
wheelhouse.
and most of them are building their packages on an Arduino. So it's like they are, most of them are, or have it anyway. They may be moving to something more fancy, but yeah, they're hamstrung a little bit, and they got to work with what they can. Just so
Well, they
you
have no
know,
budget
yeah,
like, for any of their supplies too, so that keeps them on a shoestring.
maybe that's a
Yeah.
new Ingenuity product, is a tiny little turbine controller that's programmable, and you just got
Oh,
to
that
like.
just takes all
That
the
would be
fun out
fun.
of it, Charles. I can't
I
take
love it. That's really good. Yeah, thank you, Remy. And just so you're aware, Bree, these are, in order to make it work for the collegiate wind competition, they're really small. They're like, pretty
Sure.
small. And
Yeah.
yet they still have to be able to yaw. They still have to have control. They got to come to a stop. They have pitch control. Most of them do. Almost all of them have pitch control.
Yeah.
Uh-huh.
Their variable speed. They often make their own generators. Some of them, in the beginning, we would use like a little
All
model
terrain.
airplane engine or motor, I should say. But now
Yeah.
that like a lot of them are winding their own axial flux generators kind of thing, it's crazy.
That's
These
cool.
kids are way, way farther ahead than I ever was at that age. It's just incredible. So
Yeah.
Yeah,
you
right?
should totally check it out.
Yeah.
And if you get excited about even like young kids getting excited about power electronics, if you show up to, I think CU Boulder also hosts the Kid Wind competition where we got kids from fourth to 12th grade building
No,
wind turbines. And some of the high school teams are still, winding their own generators. And they have a lot of power electronics that they're integrating because the monitoring equipment is so like you have to, you know, you have to invert it to DC. It has to be under 30 volts, or I don't remember what it is, but they have all these
sure.
regulations. And anyway, they get pretty competitive too. So if you
It's
just let
Yeah,
me
that's
amazing.
awesome.
know. But I did have another question, and Charles, not to interrupt your flow, but
No, please do.
one of the things that you mentioned, I love, first of all, that you didn't really know that you wanted to be an engineer, but you knew you wanted to be an engineer, because I think that's an
Mhm.
interesting point. Like you have
Yeah.
an affinity towards the skill sets, but you never really knew that's what you applied it to. And so, and anyway, my question is a little further down your pathway. You mentioned your internship at John Deere.
Mhm.
And I think it would be interesting to maybe if you could talk a little bit about like how you found that internship. How did you know that an internship would be helpful, and how did it help you in your career path? Because I feel like a lot of
Yeah.
college students, I mean, I think we all know internships are helpful, but like how do I even find that first internship? Did you go through your school? Was it someone in your backyard that just was like, "Hey, I got this opportunity." Like it would be
Yeah.
interesting to hear that.
I mean, so I got there was two engineers that came into my electronics class, and they basically just said that they were looking for interns. And they said they were encouraging people to apply. I actually had a friend who was interning with them, and I asked him what he thought, and he said, "Yeah, it's great." And he was getting paid well, better than what I was getting paid at the job I had. So I was like, "All right, yeah, I'll try. I'll apply." I think I'm lucky I got it. They gave me an interview. They gave me a small like electronics test. Kind of basically asking me some simple circuit questions and whatnot. But I apparently did well enough, and they offered me the job. They were hiring at that time, they were hiring several interns, so they were kind of filling up their internship program. But um, to yeah, I mean, I think for people that are kind of in that, I would highly recommend an internship to anybody who's in college who's looking to kind of move into the industry. Like, um, I think we actually here at Ingenuity, we're taking on our first intern next week, and it was somebody who just reached out to me on LinkedIn and said, "Hey, uh, you know, I saw you guys were posting a job. If you guys would be interested in, considering me for an internship or entry level when I graduate in May." And I got that. I think I got that message. It was in like my spam messages and stuff. So I found it. I messaged back to him and I was like, "Yeah, we'd be open to it." So we interviewed him and he did well. We ended up offering it to him. But I think we've got four electronics engineers here at our company, and we kind of all were like, yeah, I think it'd be nice to bring in someone who you can mentor. And I think, with an internship, it's you hope, and I think this would be a question worth asking, like is like, how will I be mentored? But we're excited about the idea of mentoring somebody who's, fresh and new to engineering and has a bright mind and is eager to learn. And so it's an exciting opportunity, I think, to like kind of pass knowledge on. And I know for myself, like I would not be where I'm at if I didn't have that internship. Partially because I don't think I would have gotten the job after I graduated if I didn't have that internship.
Yeah.
And I think a big part of why I got the job as an engineer after I graduated was because I was in power electronics, and the power electronics
Mhm.
foundation that I had just happened to be where there was the most opportunity in the company. And you know, to kind of give a plug for power electronics, I think to young people who are looking for jobs and are not sure what the job market's going to look like, I think that the power electronics field is a very active one. It's dynamic. It does ebb and flow with changing administrations, like and the price of gas and whatnot. Like can kind of tweak it, but like it's not going anywhere.
It's
And
not going to
that's
be
like
taken over by AI.
well, I mean, AI actually is an interesting case, right? It's so power hungry that power electronics, again, you need to have some way of powering AI. And I think it's one of the biggest problems that we're dealing with right now with AI is just how are we going to power AI? Even if they do reduce the power demand of AI, it's a problem for right now, and I don't know if there's any really good solutions right now. Yeah, I haven't really looked into what the solutions are. It hasn't been my focus. I think there's plenty of people that are, and uh, I know that there's a lot of momentum around changing the view or changing like research from renewable energies to powering AI, which I'm not a fan of, but uh, it's yeah, it's an interesting thing. But yeah, I don't think that AI is going to be shepherding electrons anytime soon.
That's good to know. And the one other thing that I'll just point out before I stop talking is I liked what you said about how this current intern that you're working with at Ingenuity came about, and just pointing out to the students on the call that you can see that you weren't offering an internship, but they
Yeah,
communicated with you. And it's the wherewithal to even just reach out, even if there isn't a position, that gave them that channel to encourage you to look at hiring them. So I think that's a
yeah,
message for the students out there. If you have a company that looks super interesting and they're not offering an internship, doesn't mean they don't have one. So you should
right.
definitely take the initiative to reach out, especially LinkedIn is a great channel for that. So anyway.
Yeah, yeah,
Yeah,
absolutely.
and just to add on that, Remy, is that it's so easy these days to f- to figure out to learn what people are doing, right? And you can see them on LinkedIn. You can see where their path. You can cyberstalk people pretty readily and know what kind of problems they've been working on, so that you can get informed and you can do with a little bit of research to say who have these been people been touching, who's Bree been talking to, perhaps, right? So it's easier in academia because you can see all the links between the schools and the professors and the research labs and that kind of thing. But when you can do a little bit of effort, a little bit of research to understand the problem more from more orthogonal viewpoints, right? Then when you call up Bree and you say, Bree, I'm interested in this. And how did you know when you're talking to the folks? I saw you were on a panel with some folks out of Iowa State last month. This kind of thing. I want to work. I want that kind of an intern, right? Who already knows what I do, already knows who I work with, already knows the problems I'm having, kind of thing, to the extent possible. So that's just like, if students are interested in that, do a little bit of work just so you're not asking nonstop questions. You're asking informed questions.
Hmm.
I think it'd
Yeah,
be really good.
absolutely.
I'm curious about the electric discharge machine, and it sounds like you're kind of making a plasma or something like that for some reason. What is the application? Are you allowed to share
It's
that, or is it?
uh, yeah, I think I can share it. It's just it's e electronic discharge machine. It's for building like jet engines.
Oh,
And so they've
oh, as
got
this sparker, you mean, as the
yeah,
igniter?
exactly. For
Yeah,
yeah, for like precise like, burrowing through. I had kind of no idea when we talked to the guy, but they're
yeah.
having issues or they want to improve you know, their control a little bit. And so we're going to be working with them to do that. And it's kind of we just heard that they wanted to move forward with the project just like this morning.
Wow.
So it sounds like, and it's a exciting one. I think, in my kind of broad explanation of like what I do, where it's, controlling electrons and the flow of electrons, like, that can be like you were saying, like from solar onto the grid, it can be for, wind turbines, or it can be spinning motors for an electric vehicle. It could also be controlling an arc for like electronic discharge for, who knows what. And I don't know. I sometimes I'm baffled by the broadness of like the career that I'm in and the very broad applications that it can be applied to. And now I have to figure out how to control an arc.
There's my son sent me a YouTube video of this crazy engineering student. I mean, he must, I don't know. But anyway, he was the one that was like, what can I do with 100 car batteries that can each deliver 800 amps?
Wow.
Have you seen that YouTube video? And he's
No,
like,
I haven't.
got them all in series, or no, it's sorry, all in parallel. So it's only 12 volts, right?
Okay.
So he's like lying on this mat of batteries, but he's like using it to burn through like 3/4 inch bolts and things like that. Just what to do? What are my problems if I'm trying to discharge energy through something? What can I learn by doing it at different voltages, different
Yeah.
currents? Obviously, there's plenty of current to go around when you've got 800. I guess it's only 80,000 amps, but 80,000 amps is a lot of amps, right?
A lot
Uh,
of amps.
Oh
Yeah.
my.
Enough amps to do some damage. Yeah.
yeah,
Yeah.
that's so
Um,
fun.
I want to be aware of our time. We got about 10 minutes left, and I know Ram is on the call and Janelle is on the call. So I wanted
Yeah,
to just kind of make sure we had an opportunity to open up if anybody else had any questions for Bree.
thanks for me.
Yeah.
Ram, yeah, anything you want to ask, Bree?
It's good to see you, by the way, Ram. Good to see you.
Yeah, that's really very interesting conversation. At some point in my life, like I was on a microgrid project. It was called Miracle, and that's where
Oh
I
yeah,
learned ABCD of power electronics. That was exciting,
Yeah.
yeah.
and it was really good to hear from you. My background is mechanical engineer.
Okay.
I gave it a try. I learned a lot. I'm not doing it anymore, but it was a really great experience.
Excellent. And we
Yeah.
saw from Janelle that she doesn't have any questions, but that's okay. Ram, I should have thought. I was just up at App State yesterday, and because I ran up to Beach Mountain to take a look at that Sunsite turbine up there. And if I had
Awesome.
thought about it, I would have reached out and said, "Hey, you want to have lunch?" Shame on me.
That'll
That's
be
all right.
awesome. Next
Next
time
time.
you'll be around, please just give me a heads up.
I will
You
definitely.
will find something interesting. And we have a wind farm on campus now, the two V47, like you were talking earlier about it, and the one NPS 100 kilowatt. It's
Yeah,
really cool, and you see an amazing view from the 421, and it's very impressive, especially in the sunshine days.
I bet. That sounds so
that's so
cool.
amazing. Yeah,
Mhm.
amazing. So Bree, if you had a magic wand and you could wave it over Ingenuity, so Ingenuity was doing something in clean power, what would that look like? What would you hope it could do?
If we could do anything in clean power,
Yeah.
um, that's a good question. I guess I don't know. I mean, to me, I feel like, we consult, and try to help people bring certain ideas to market. If I could do anything, if it was someone was gonna like let me loose on something, I feel like I would want to like be given the job of like, you know, electrify the United States with renewable energy. Like, I just feel like all of the technology is there, and I just feel like someone needs to just like figure out a like technical plan for, transitioning to sustainable energy and then execute. And I feel like, I'm kind of I like to think of myself as a big picture person, more on the forest rather than in the trees. And I just feel like big picture wise, I'm like just wondering, is anybody doing this? Like, is anybody actually like putting it together, like all the pieces of the puzzle? Because to me, it feels like, when I think about like clean energy, and it's not that the technology doesn't exist. And I think, like, there's just specific problems and unique ways, I think, that uh, you know, unique challenges that I think different areas have. And I think if we took a bigger zoomed out picture of our problem, and I think we've got some serious problems in this country where we're not solving, or that we're taking the wrong approach towards solving it. I just feel like if we could put together like an actual technical plan towards moving towards clean energy, I feel like that would be a very fascinating project. Because, like, I think when you start any type of problem, you start out with like a big picture, you have a goal, and then you uncover problems as you go and you get more into the details. Um, and I would love to just uncover all the many challenges, uh, and I guess be let loose on, making that transition, I guess, for a as big of a country as the U.S. is, and try to make that initiative happen. Um, I think, yeah,
I'd give you money to do it if I had it.
it's like someone,
Sounds
Well,
like a great idea.
there
yeah,
was actually there was a renewable electric futures study, a 3 volume or 4 volume series that came out of NREL. Maureen Hand, who's actually the wife of Ryan Weiser, who Ryan Weiser writes the wind market study out of Lawrence Berkeley.
yeah,
Anyway, so Maureen Hand was one of the original sort of leads on that project, I think. And it was a technical look at like how far
yeah,
could we go? And yeah,
right,
we could hit 80, 90%, no problem. There is no technical reason not to do it. So it's just about will. And we were on our way, right?
yeah,
Under Biden, we were on our way, and the utilities were like, okay, we're not looking back. We know what we're doing. And now we've got an administration that's saying, you know what, for resiliency or energy security standpoint, we got to fire up these old coal plants to the tune of $1 million of extra uh, operating costs to the ratepayers in that utility per day, right?
yeah,
Just because, and you don't actually need it. You can shore it up with batteries. So I think, your comment about AI is interesting because it is, you always have to have your back to something to get creative sometimes, right? We are a very complacent species. If we're fat and dumb and happy, we just are fat and dumb and happy. And and we don't do anything. But when we
Yeah.
see an opportunity like this, we're seeing our grid becoming a hybrid grid, just like our first hybrid electric vehicles. And we
Right.
know that we pick up tremendous efficiency from that. So if AI is going to force us to play that hand, then let's learn from it. It's the next thing.
Hmm.
And so if you were to give some advice, if you're sitting down across the table from a senior who is, a few months away from graduating, what advice would you give them based on what you know and what you've been through?
I guess I would say my advice is to try to build up your career with as much like anti-fragility as you can. So anti-fragility being a concept of like, you know, gaining and getting more robust with like more disorder and more chaos, I guess. And I think, you do that by trying to build new skills in your repertoire. Don't tunnel into a job where you're just doing one thing and, you know, you become that guy that does that one thing because that thing might become obsolete, and then all of a sudden you
Mm.
might be going and you might be unemployed, you might not be able to get a job because that skill's not useful. Try to get as many broad and useful skills as you can, because I think there's a reason to be a little bit anxious about, where the market is headed, where technology is going. You don't know where it's going to go. And so trying to build in some resiliency or anti-fragility to kind of the ever-changing landscape of the world is a good idea. Um, you know, I have kind of tunneled it. I guess I have kind of focused on like power electronics, but that has a lot of broad uses like I was talking about. And so um, I think do what you can to kind of broaden your skill sets to be resilient to the changing markets in the way that the job landscape will kind of look in the next who knows how many decades. You know,
That's really good advice, I think.
Yeah,
Yeah,
yeah.
definitely.
yeah.
Very
Um,
good. Well, Remy, you probably have some closing things you need to close with, right?
just, wanted to remind folks that our next call is going to be March 18th, at 2 o'clock, and we are going to be meeting Kate Chunk. She is with Advanced Energy United, and they have internship opportunities they want to talk to us about. So
Oh,
if you're looking for
nice.
an internship, this would be a good one to join. And I think they do a lot of different things, but that'll be worth connecting. And so, other than that, it's just a big thank you to Bree for being here. And Charles, thank you for facilitating the conversation. And I look forward to seeing everybody next week.
Yeah. Thank you so much for having me.
Yeah,
Thank
thank
you,
you,
Bree. Really
Ethan.
appreciate it. We'll grab a lunch soon because you and I need to catch up.
And
Yeah,
I'll send you
absolutely.
the CWC information because I would love to see you
Yes.
there.
Yeah.
Yes, please do.
Okay.
Awesome.
Okay. All
Thank
right.
you.
Take
Awesome.
care, everyone.
Yeah, take
Bye.
care.
Cheers. Bye.
Bye.